Good morning all. Today we will be talking about obturation. So basically, coming to an introduction of obturation, it is achieving a high quality root canal filling, which is one of the prerequisites for success of the root canal treatment. The root canals should be filled as completely as possible in order to prevent the ingress of nutrients or oral microorganisms. The obturation is basically reflection of cleaning and shaping and is evaluated on the basis of length, taper, density of the guttapercha removal and coronal seal. So coming to the definition, the obturation is basically three-dimensional filling of the root canal of the entire root canal system as close as possible to cemento-dentinal junction, overfilling or underfilling, without overfilling or underfilling. Now, why do we obturate the canal? Basically, there are three reasons. First, we should stop the coronal leakage. Secondly, we should entomb all the microorganisms within the root canal system. And third, so as to prevent the percolation of fluid from the apex. So, these are the primary functions of the root canal filling. Now, when to obturate? The question is, when do we obturate the root canals? So, first of all, the tooth should be asymptomatic. There should be no discharge or pus drainage. There should be no foul odor from the canal. There should be no draining sinuses. Then the temporary filling should be intact. So inter-appointment fillings basically, and negative culture sensitivity test that we used to do earlier. Now the ideal properties of the root canal filling or obturating material are, it should be easily inserted into the canals. It should not shrink after being inserted. It should be bacteriostatic, that is, should not promote any new growth of the bacteria. It should not stain the tooth structure. It should seal the canal laterally as well as apically, that is, three-dimensional sealing should be there. It should be impervious to moisture and it should be radio opaque. First, in the previous time, silver cones were used for obturation. These are the silver points. These were introduced by Jasper in 1933 in the era of 2D obturation of the root canal. The single cone was used. The advantages were stiffer and easy to use and easy to insert in narrow canals and appeared dense radiographically. But disadvantages are, they require a circular preparation, they lack plasticity, so no seal was acceptable, and remaining space was filled with cement or sealer and it would be washed away or reabsorbed with time. Then came use of guttapercha. Guttapercha is basically derived from an English word that comes from a Malay origin, that means guttaperca, that means a strings of sticky plant tissue. Guttapercha is most popular core material that is used for obturation nowadays. The advantages are its plasticity, it is easy to manipulate, it has minimal toxicity and it is radio opaque. So, it can be easily seen on the radiograph and it is easy to remove by heat or solvent. Disadvantages, it lacks adhesion to dentine, but when heated it results in shrinkage upon cooling. So, low viscosity guttapercha flows easily into intricacies of the root canal, that means into accessory and the lateral canals. Therefore, and the condensation forces are also lower as compared to the high viscosity guttapercha. So, low viscosity guttapercha basically are used in thermofill techniques or in obturation of the lateral canals. So, composition of the guttapercha, it consists of guttaperca, that is 24.5%, zinc oxide, titanium oxide, BHT, bisphenol A diglyceride ether, zinc stearate and dentacrylate. So, there are various types. They come as pellets or bars for thermoplasticide obturation techniques, as syringes like low viscosity sealers, or to be coated as carriers like thermofill, or pre-coated core carrier guttapercha like for stainless steel, titanium or plastic carrier is coated with alpha guttapercha like thermofill. Medicated forms of guttapercha are also available like iodoform containing guttapercha, calcium hydroxide containing guttapercha, chlorhexidine containing guttapercha and glass ionomer containing guttapercha. Resilon, it is a high performance industrial polyester which is also used alternative to guttapercha. It is available as cones or pellets. It consists of soft resin matrix, polymers of polyesters, fillers and radiopacifiers, bioactive glass, bismuth oxychloride and barium sulfate. The advantages are excellent sealing characteristics due to creation of monoblocks. 6 times it is more resistant to shrinkage and shrink only 0.5% when heated. Then Endodontics system was introduced. In this, conventional gutta-percha were coated with proprietary resin coating. These coatings are bondable to hydrophilic methacrylate based dual cure resin sealers. Now coming to sealers, which are used in conjunction with the gutta-percha. So basically they are responsible for principal functions of final root canal filling. They seal off the root canal system and entomb the bacteria. Filling of irregularities are also done with the help of sealers, and several different chemical formulations have been used as sealers. So coming to classification of sealers, they can be classified as zinc oxide eugenol based sealers like Grossman's, Roth or Tubli-Seal, calcium hydroxide based sealers like Seal-Apex and Apexit, glass ionomer based sealers, and resin based sealers like AH+, AH26, Epiphany and Dikit. So sealers, once the canal are prepared, then they are dried with the help of the paper point. The sealer is mixed so that it appears with a one string consistency. They are mixed and then applied on the gutta-percha or with the help of the lentillo spiral, and then they are used for filling in the root canal system. Sealers can also be applied with the help of lentillo spirals. They coat 90% of the walls, so they are the preferred method of using lentillo spiral. Then methods of obturation of the root canals. According to Cohen, there are various methods like cold lateral condensation, warm vertical condensation, continuous wave compaction technique, warm lateral compaction, thermoplasticide injection technique, carrier based gutta-percha, thermomechanical compaction solvent technique. Cold lateral compaction, in this basically first we require canal preparation, then spreader selection, accessory cone selection, master cone selection and sealer selection. In this, the accessory cone, they must occupy the space left of the spreader. Then otherwise an air will be sealed and filled, the space will result. So condensation and addition of gutta-percha cones, they continue until the spreader reaches no more than 2 to 3 mm into the canal. Then comes tailor-made gutta-percha cones. In this, we roll the gutta-percha with the help of the glass slab, and then we insert it, and thus we are customizing or we are making the gutta-percha cones. Warm lateral compaction technique, it is variant of traditional lateral condensation. In this, a heated instrument is introduced into the tooth already obturated by lateral condensation to soften the gutta-percha and enhance the adaptation to internal anatomy of the canal. Warm vertical compaction, in 1967, the Shielder advocated as an alternative technique to cold lateral condensation or silver points. Methods of filling the radicular space in 3 dimensions, it has the ability to adapt to warm and soften irregularities, lateral canals within the root canal system. Thank you so much.